Welcome to this video. Today we're going to review what we learned in 4.1 and 4.2 notes. So looking at this graph, we're asked to identify where the local maximums and minimums are, and then where the absolute maximums and absolute minimums are. So in terms of local maximums, remember that's just, for a local minimum, it's just the lowest point around it. It's not necessarily the lowest point of the whole graph, same for the local max. Whereas absolute and absolute minimum and absolute maximum is either the lowest or the highest point of the entire graph. And in this case, since our graph has endpoints starting at 1 and going to 5, this would be saying at what x value does it have the lowest point of the graph on that region and then the highest. So here we're asked about at, so we're looking for the location. So we see a local minimum. There is a local minimum here at 4. Okay, so we would say at x equals 4. We see a local maximum at x equals 2. And we also have a local minimum at x equals 1. And a local maximum at x equals 5 as well. And in terms of absolute minimum, we see the absolute minimum is at x equals 1, and absolute max is at x equals 5. Next, we're going to look at a very similar graph. The only difference is here we see at the endpoint at 5, we actually have an open circle, so it's not, we don't actually have a value of this graph at 5. The only thing that would change is the fact that we no longer have an absolute max at x equals 5. So in this case, we only have one local maximum at x equals 2, and then no absolute max. Next, we're going to review the definition of critical points. We have that a function f of x has a critical point at x equals c if, first, the x value must be in the domain of the original function. Then, if x is in the domain of the original function and either the derivative at c equals 0 or the derivative at c does not exist, then by definition, if these two are met, x equals c is a critical point. Let's remember this definition and look at a few graphs to identify where in the graphs we have critical points. So we're asked to consider the following graphs and identify which of these two graphs has a critical point at x equals c. In both of these graphs, we see that in this case, the derivative of f at c does not exist, and the derivative of g at c does not exist. So they both fit criteria 2 of being a critical point, but this is not actually a critical point because remember the other part of the definition is that the point in question must be in the domain of the original function, and we look, c is not in the domain of g of x. So since c is in the domain of f of x and the derivative at c does not exist, then we would say that the answer to this question is that f of x has a critical point at x equals c. If we're asked the same question to determine which of these two graphs, h of x or m of x, has a critical point at x equals c, think of the following two graphs and take a moment if you like to pause the video. Whenever you unpause the video, we'll display which of these graphs has a critical point, and when you find the critical point, identify what criteria is met. Looking at these two graphs, we see that actually at c, the graph h of x has a positive slope, the slope of the straight line. So the derivative is actually positive at c, so it's definitely not equal to 0, so there's not a critical point of the function here. But looking at m of x, we see that at c, we've got a horizontal tangent line, so the slope of this horizontal line is 0, so the derivative equals 0 at c, and furthermore, c is in the domain of m of x, so this is our graph with the critical point at c.